going to talk about a project I've been working on for several years, living in the world of WBEM, CIM, in particular the SMI specification for SNIA. And I'm going to refer to this general chart several other times. And all I want to point out here is that this is the basic setup for a whole set of specifications tied to the concepts, tied to the keywords WBEM and CIM. And they involve the idea of web-based enterprise management, a model, the common information model, but what people have been ignoring for years, and we want to put in and specify, because this is the whole key to SMI, is the concept of profiles that use these two technologies to achieve particular management goals. Okay? And there's a whole set of specifications tied to this. The DMTF has specifications of the model, the operations, the profile concepts, particular initiatives like Smash and Dash. SNIA has a fairly significant, extremely large specification called the SMI initiative, SMI specification. It's interesting, okay? Now, for those who want to get the 2-minute shot, I'm going to give you 2 slides, and if you understand it all, you can leave at that point. Otherwise, we can go back and fill this out. So PyWBEM is the name of the project. It's obviously Python because it's the Py part, and it is WBEM based. And what it is, it's an implementation in Python of the DMTF SimXML client crossing a whole set of Python versions, clear back to 2.6. This is not a new piece of code. It was actually started clear back in 2007. Pretty much abandoned for a long time, and a guy from IBM and myself picked it up and started working on it about 2 years ago, and we have grown it, extended it, finished it, etc. The reason we go back all the way to Python 2.6 is because it's still used heavily by Red Hat, and they're still living in Python 2.6 in some of their platforms. So if we take away Python 2.6, the next morning we get a lot of screams. It supports the DMTF SimXML protocols, the CIM model we'll talk about in a minute. It has a library complete with a set of Pythonic interfaces. We've got to use the word Pythonic here for communication with WBEM servers, and it includes not only the client library, but also the ability to manage indications. It's open source, freely available. It's multi-platform because it's Python. It's run and tested on a regular basis on Windows, Mac, multiple varieties of Linux. It's a strange word to say, but it's maintained. We've got 2 people working with it. We do a couple of releases a year. We fix issues. We had a couple of issues, and we're only part-time on this, but we had the fixes out and released the people within 2 days, about 2 weeks ago. Our next release is the 4th quarter of 2018, and I'm not going to get into exactly what we do in each release because basically if you get it, you take the latest release. We consider it to be a complete representation of these set of specifications, in part because we worked at it, also in part because between me and my partner, we wrote a lot of these specifications. So we consider it complete, it's tested, it's compatible with both DMTF and SMI specifications as we stand now. User ready, downloadable, installable. It's a standard Python package, you download it with the standard Python tools. Uses the LGPL 2.1 license only because that was the license originally put on it, and anybody who's worked in open source knows it's next to impossible to ever change a license. One of the ground rules is you got to find all the original contributors, and there ain't no way. Okay? And I'm not going to get into uses at this point, but as far as we're concerned, it is a core library to use if you're going to use Python and any of the WBEM facilities. And it includes both, not just the core library, but diagnostic and a set of support tools. What was our goal in this? We backed into this. We want to make it easy to write clients for WBEM, CIM, and particularly for SMI. Okay? And I think it took a long time to come up with that one sentence as a goal. In fact, I finished it about an hour ago. We want to then also make it easy, particularly with SMI, to be able to automate the functionality of a client working with implementations of the SMI specification. As I said, availability, it's a PyPy package, it's on PyWBEM, and the project is on GitHub, and it's PyWBEM. Okay? So this is generally what's in it, and we'll go through that in more detail later. Next. Well, wrong direction, sorry. Where's this project going in the future? We're not done. We're probably going to release a version 1.0 in the near future. Every project finally gets there, because that's the point you can do some incompatibilities. When we release the 1.0, we're going to get rid of 2.6, Python 2.6. That is one of the biggest hang-ups we have in this environment. The other one be some libraries we've got in Python 2 that we can't get rid of until we get rid of Python 2. So where are we going in the short term? We've actually got a command line browser that uses it as one of our test tools. We'll release that in the next few weeks. We're going to do another release of this package. Nothing significantly major, cleanup, extensions, improvements. And one of the things we do in every version is everything that goes in new goes in experimental. You're warned, don't use this for production in this version. And then in the next version or so, we change it to non-experimental. And from then on, that API is frozen. So we've got about 3 or 4 experimental pieces of functionality in this version, and we will change most of those to non-experimental for the next version. Every time we do it, we try to improve some performance and add functionality, okay? And then we're also trying to grow more and more tools. And in particular, we want to start another project, and we'll go into with this more in a minute, but that is to move beyond the functionality that is the PyWBEM we have today up into implementing the actual SMI profiles themselves, and to add more tools on to be able to use this. So the things we're going to do, other than the general blah, 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 there's a set of base classes that represent the specifications. We're going to add some more of those, the generic ones. We're going to start to implement actual profiles, so we can pass out code to people so they can actually get direct access to the resources and characteristics of any SMI profile with just a couple of lines of code, and we're going to extend the tool set. Now I can't even tell which direction. There. Okay. So I did this with the idea of talking to clients, okay? In the past, we've done a lot about implementation and stuff like that. We wanted to talk to people who are going to use it and consider it as a client tool. One of the things we felt we had to do is go back and put some terminology on it. And let's go through this really fast. WBEM has one defined infrastructure. It consists of 3 components. It consists of a client, a listener, and a server. You do operations and responses between a client and a server, and you can have a listener, which will receive some indications from a WBEM server. So client, listener, server, and these are the interactions. The big circle is the things we implement in PyWBEM. So when you see a red circle like this, you know, that's something we did in PyWBEM. The basic architecture consists of these 3 pieces. It has a defined set of operations, get, enumerate, blah, blah, blah. It has a concept for events and indications and how you subscribe to them, and it has a set of built-in query languages. Protocols. Over the years, WBEM supported a number of protocols, but the one that became universal was, thank heavens, the one we started with. And that's the one that this particular technology, PyWBEM, is based on that protocol, pure SIM XML, and that protocol is integrated right into the environment. So out of the package, this thing is ready to talk to any compliant WBEM SIM server. The model, the SIM schema. We get into a lot of complication there, and client people are going to say, why do we have to worry about this? Only because you on the client see all of these things as PyWBEM classes. So within the model, there's the concept of a class which has names, its place in the hierarchy, Qualifiers, which define it, properties and methods. Properties have names, values, and qualifiers. Methods have parameters and return values. Qualifiers have characteristics such as the scope. Is this applied to classes, properties, methods, et cetera, and certain data types. And every one of these things has a corresponding mechanism defined in our implementation. So there is a Python class for sim class, a Python class for sim class name, a Python class for sim instance, et cetera, et cetera, et cetera. And that's part of the public API. By the way, we'll get to it. The only thing I'm going to say about qualifiers, they qualify the various pieces of data, which was a profound statement. And keep in mind, there's some key ones that we want to keep in mind. A key is a qualifier that says this property is a key for this instance. It's part of the naming mechanism. An association we'll talk about in a minute, an indication, they're identified by these idea of qualifiers applied to the particular component of the model. SIM has different types of classes. The SIM class is the core. And in reality, everything is defined by the SIM class. So you've got the core SIM class, which has key properties, which allows you to identify the instances of that class. The collection of key properties is the name for an instance of that class. You've got a special class for developing associations. That's relationships between other classes. And that differs from the original class in that it has properties that are actually references to other classes and instances. And finally, it has another type of class identified by a qualifier, which is the indication class. And the key to it is it's not persistent, therefore it has no identifier, no keys, etc. And the beauty of it, it's all just SIM classes. Okay. Associations, very simple concept. You got a class that is an association, it points to two others. You've got an instance that an association points to two other instances. If everybody says they already know this, we can just go chugging down the street. But maybe that'll just throw my whole presentation in this. Okay, we got specific data types in SIM. And those correspond, data types, Boolean, character, string, all of the various uints and sns, real, date time, an array, which is not a data type, but let's not get carried away with protocol here. And they're all represented by specific implementations. So Boolean is Python bool, char16 is Python string, et cetera, and we control that throughout our implementation. So we fully implement all the data types that are in the SIM model. Okay. I'm not going to worry about this one other than to note the SIM infrastructure defines the meta schema, which defines the basics of the model. It's pretty well based on UML. The schema itself, packages of classes, etc. The rules, the constraints, which represent the specification for the model. And finally, an a language definition for defining the source code for classes, instances. And that's called MOF. And we will see more of MOF as we work our way through this. SIMOF is a fairly simplistic language. Defines SIM classes, instance qualifiers, and methods. That's the language used by the DMTF and CINIA to define release SIM schemas. In addition to being a model, the DMTF, for example, every few months releases a complete collection of classes that represent the broad spectrum of things that are managed. It's about 3,000 classes in that collection right now. That's the general release of the DMTF that people use and refine to develop management mechanisms. Okay. I mean, simplistically, this is what it looks like. That's a qualifier definition. That's a class definition, which basically defines a bunch of properties. And here is a qualifier that says this property instance ID is a key. Okay, and here is the definition of an instance of a SIM-foo, which has a particular instance ID and a particular integer property. The reason we bring this up for us is that in addition to supporting the basic infrastructure, PyWBEM also has a compiler, supports the compile, the building of these models. We can actually build them through our compiler. We can send them to our own client. People use that. We're using that for documentation. We're using that for building mockers and other things. And you could even send them off to a web server. We, for example, can create these things and send them off to a variety of different web servers to use. Very quick. In addition to the idea of getting data and putting data, the CIM concepts also include the capability to generate events, which they call indications, and to subscribe to those events. So indications are representation of specific events sent by a server to a listener. And subscriptions, normally generated by a client, define the activation and characteristics of specific indications. And again, this is all just within the model. And so you have 3 classes in a subscription. You've got the subscription, which consists of a filter, which defines what you're going to subscribe to, and written in a particular query language, CQL normally. And you've got a listener, which says, I want you to send it to him. So this is normally a destination URL with a port, and this is normally a CQL query definition, which defines the class or the event characteristic that you want to send. Now we're to the heart of this whole thing, which is what we haven't covered significantly before, profiles. Okay, DMTF releases a mega collection of model components, some 3,000 components. I cannot give you that and expect you to manage anything. So, a number of years ago, they started to come up with the idea of profiles, which basically, that's a subset of the schema. It's not anything new. It's a subset of the DMTF schema, or DMTF and or your schema, which defines a particular management domain. Manage array, manage software identity, etc. Then it defines what is managed by a server and how to access the data that the server maintains about that profile, the characteristics on the resources he's trying to manage. So what it defines really, it defines the resource classes that you're going to manage, the associations between those classes, the indications that you expect, the methods you can execute into this server, and then another characteristic which calls scripts, were basically the interaction of a number of things to accomplish a management task. Now, the reason this comes up is 2. Number 1, I can't give you the 3,000 classes and expect you to do anything. So you want to simplify it down to the things you need to accomplish one target. And second, the generality of the model is typically more than you would need to manage one thing. So in essence, you simplify or add constraints to the model, remove things from properties that you aren't used in this thing, set fixed values on other properties, make some things optional, other things fixed, other things mandatory. And that's how you adapt the classes for this particular profile. And by the way, the SMI profile by the SNIA is in effect an enormous collection of these profiles. And that's why I said it's the heart. That's the heart of SMI. DMTF defines the models. SNIA defines the profiles to accomplish particular management, or to manage particular domains. Now, one thing to be careful for, we'll go into it. Profiles are not monolithic. You know what's causing this? There. To manage an array, you may want to manage the array characteristics itself. You may want to manage the software associated with the array, the identity. There's an entire collection of things. And yet, software, you may want to manage over a whole spectrum of things. The whole concept of profiles was broken down into autonomous profiles. That's the top level. That's a product level. And then components And when you read the specification on a particular autonomous profile, it will define all of the component profiles that are part of that. By the way, all this sounds like Greek, except the client has to understand at least some of it in order to write a client. Okay. Schemas, it's the broad set of everything. Profiles, a subset of the classes adapted for your management. It has constraints. It typically has usage definitions, use cases, and scripts in it, and it also includes specific indication definitions. So you, the client, can manage an array. You, the client, can manage the software identity, et cetera, et cetera, et cetera. Just as to give you a quick example, the DMTF, excuse me, the SNIA array profile, that profile has 32 other component profiles, block services, health indications, target, blah, 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 blah. Those are all mandatory. No, excuse me, these are mandatory. Then in addition, you got a whole set of others, software, et cetera, and those are all optional. So in order to implement the array profile, you don't have to implement the software. Has a total of 9 resource classes, resource and association classes, and of that only 2 are mandatory. One word that's going to come up here a little further is the difference between a profile and a registered profile. A profile is a document in the SNIA SMI specification. A registered profile is a structured way to understand what a WBEM server will give you in terms of profiles. You can ask the server, what profiles do you support? I support array, and I support the software component of array, et cetera, et cetera, et cetera. So the minute you see the word registered profiles, you're down into asking the server questions. I'm going to skip that one. We're going to get too complex here. How are we doing time-wise? I forgot to turn. I don't even have mine.
It's 5 o'clock.
So I got about 20 minutes. Okay. And I'm talking about this because it's some things we're working on. The key is, I have a client somewhere, and I want to talk to a server that I think is an SMI server, and I want to find out what that server is capable of. What profiles does he implement? Does he an array server? Is he a NAS server, et cetera, et cetera, et cetera? Okay? And that's done through this registered profile concept. And the server maintains a collection of profiles that are registered with him. I am the SNIA array profile version 1.6.1. And that, in turn, points off to where the actual implementation of the profile is in terms of 2 concepts we're not going to talk about anymore, but you need to know, if you get in further, in the concept of a central and scoping class. And those are the things that say, that's the starting point. The profile registration takes me here, and this is the starting point. Everything dealing with that profile is buried underneath there. And the implementation of the actual profile is here in terms of its classes. Okay? The method to get there is right here. And that's all done, that's part of the client requirement to be able to get from the server through the registration to here and down to the profile he wants to work with. Okay. I think I'm duplicating things here. All I really wanted to say here was in defining profiles, SNIA and the DMTF has 200, 300 profiles in 2 big initiatives. And SNIA, I have no idea how many profiles are in that spec. But basically, you start with a set of goals. Usage for this profile. What do you want to manage? What are the use cases? What are the pieces you want to take from the schema? You adapt them, so you create class adaptations for the profile. I want to use this class, but I want these limitations. I want these properties to be mandatory. I want these to be optional, et cetera, et cetera, et cetera. So you're limiting the things that are in the model for this particular adaptation. You define your particular indications and subscriptions. You organize your central and scoping classes, and then you include cases and example scripts, and voila, you have a profile. That's what I wanted to cover as background. Now we're going to go into what PyWBEM is today. Okay, these two red lines represent the public API for PyWBEM. It defines the ability to make connections to a server and to execute operations against that server. Predefined operations. They're well defined, and we'll show you a little bit about them in just a second. It has the ability to define all of the objects in the model. SIM class, SIM instance, all of those things are built into PyWBEM. So you've got, here are the objects, and here are the connection and request methods, okay? It has a set of higher level classes that represent higher level concepts in the WBEM SIM modeling structure. And the two we have in right now are the concept of a server and the concept of a subscription manager. And a subscription manager manages the creation of indication subscriptions between itself and a WBEM server. The server class manages the general capture of information about the server, and we'll go into that in a minute. And then finally, we include a WBEM listener in this. And then also, didn't show it, but down at the bottom, you've got all of the protocol mechanisms to be able to communicate with the server using the standard protocol. Data types, we've been through that. I think we've seen the SIM objects. You might as well. Very simple. There is a Python class called SIM class, a Python class called SIM class name, all the way down here. Every one of these things, but only one of them, not two of them, has a class with the ability to construct, methods to work with it, methods to transform it between the different forms. I can convert it back to the standard, the MOF format we talked about before. I can get data from it. I can add data to it. I can create them locally and send them to the server. I can get them from the server and display them. The operations all fall down to get one, get a bunch, create, delete, or modify. That's it. So all of the things, classes, instance, qualifiers, I can get them, I can enumerate them, I can create them, delete, modify. The enumerate means different things to instances than it does to classes. Get classes means get me a bunch of classes. Enumerate instances means gets me instances of this class. Okay? The invoke method, the invoke method is defined as part of a class. That's methods you want to execute on that class. And so that method executes on either that class or a specific instance of that class. There are two special operations for references and associators. Because references use this model of something in the middle, here it is in the middle and it points to A and it points to B, it's not easy to get from, this is my endpoint, tell me about this other endpoint. Because as a user, you have to go and look down through the middle, say who points to me, and then, aha, he points off here. And there's several characteristics tied to that, names and stuff like that that you can filter on. So these two operations were specifically included to force the server to do that or somebody else to do that for you. So if you want references, you say, tell me all the associations for this instance or this class. If you want to find out what's at the other end, you tell me all the associators for this instance or this class, okay? The operations support the concepts of pull, which basically means, really not word partial, but get results in segments. One of the things we found out after the whole environment was up and running was we all had scalability issues. You know, people were building models with 1 million objects in it, and nobody wants to ask for 1 million objects. So we built an additional pulling mechanism, said, open it, now give me 10, give me 100, give me 1,000, give me 20, whatever. Okay, all errors, every error that occurs comes back as typically as an exception to the user in PyWBEM. So all errors, in essence, are out of band. If I ask for something and something is wrong, I'll get an exception. The return data depends on the operation type. Obviously, enumerates, associators, and references return lists of things, instances, names, classes, etc. A get returns one of an instance or a name or a class, etc. The invoke method returns two things. He returns a value, and that's the one case where what you can interpret as an error isn't covered by an exception. So if you get a failure of the invoke method, you get an exception back. Other than that, you may well get a return value, which is not an exception, but you have defined this method to say any non-zero return is an error for this method. And then you get a set of parameters back, which are just data encapsulators. You can create, you can modify. Obviously, the creation of classes is somewhat limited, but the creation and modification of instances is used successfully throughout the model. And then what we call the pull operations are those operations that get partial results. There's a single class in the environment called WBEM connection, and it's a bad name for something that's terribly important. That's the mechanism that lets you talk to a server. It allows you to connect to the server. It's a lazy execution method. The actual connection, the constructor doesn't do anything. He just puts the data away. Basically, this whole model was built on the HTTP model, so you only get anything interesting happening when you make the first request. And the type of data that you supply to it, the URL, the credentials, namespaces, we haven't even talked about that. Certification keys, certificates, limitations like I don't want to verify what the server certificate if I get one back, timeouts, things like that. The reason I picked this one over here, put it in red, verify callback, is that's one of our little hang-ups in life. The original code we got was based on an SSL library that had a callback to give you the verify. How many people here use Python? Okay. There is no such thing in requests, is there? So what we've got is a callback right here that only is implemented in some cases, which means that the user could be doing things that we don't know in verification, so we had to leave it as it was. That's why one of the reasons one of the limitations we got. We didn't dare take that code out because we don't know who's using it for what, and we really don't want to honk with their security issues until we make a major change. Simple example, make a connection, get a handle back for the connection, enumerate instances, and I'm enumerating instances of the class, computer system, SIM computer system, and then I'm just printing them. Get the names only. I didn't change the name to enumerate instance names. And if I change that to enumerate instance names, he just returned the names of the instances instead of the instances. And this was an optimization in the original model, which today doesn't gain you a lot, because this returns the names also. But when this was started years ago, we were over-optimizing. Okay. At this point, we got a number of higher level objects, all deal with the getting information from the server. WBEM, CIM have a concept, like everybody else does, of namespaces. It's really nothing more than a uniqueness identity separator. I can put things in different namespaces, and the names have to be unique. The names of the instances must be unique in that namespace, but they don't have to be through the environment because the namespace is an attribute. But we needed to be able to get it. So you can get access to the server, find out what the interop namespace is, what all the namespaces are. Remember we talked about registered profiles? You can ask, in one line of code, you can get all the registered profiles and figure out what they are. I could show you how, but I don't trust doing demos in these things. You can get the name, the brand of the server, what version of the server is. And this is the fun one. I can now, with one or two lines of code, get all the way down to the implementation of that profile and begin to work with the data in the profile. Indication support in PyWBEM, I think it's relatively complete. Basically, we've got the PyWBEM client. We've got a whole class for managing subscriptions, getting the data, creating the subscriptions. There's an interesting issue here because a subscription here means nothing. The only time a subscription applies is when the server and its profile understand it. So we create them, we send them, create, delete, da-da-da-da, and send them, and then off of that, he will send indications. However, these two are asynchronous. So how do you manage the issue of when you get rid of a subscription? So we define two techniques. If I own this subscription in closing this client, or in fact this whole subscription class, I will automatically delete all the subscriptions over here, assuming he's still alive. Okay? And even if he's not, next time we start up, I'll revalidate him to bring ourselves back into sync. If I say I don't own it, I just leave it on this server until he or I decide to get rid of it. That subscription will say, I want you to send this particular indication based on a query, this class, blah, 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 the creation, the deletion, all these sorts of things, to a listener defined by a URL and a port. And over here we've got a listener which runs on a set of independent threads, accepts indications, processes them, and can do whatever you want to. List them, queue them, pass them on down to the original subscription class. So, having spent a lot of time writing clients in C++, this is an example in PyWBEM of creating a complete set of subscriptions and then for removing them. We didn't get any indications with this. We actually created the listener, but we didn't process any indications. So, big deal, just the set of classes, make the connection, create the server object from the connection object, start the subscription manager, which is the one we list as subscriptions, and then link that, link these together, start the indication listener, and all it is, I'm saying send them back to me, and yeah, that's right, send them back to me, create a filter, and the filter is just a query definition. In this case, is select star from whatever the test class is. In this case, it's test indication provider class, okay, and the query language. Now I want to create an own subscription, which means it's mine, and it's tied to this particular server ID, which I created up, and it's got a filter path. By the way, then the destination part is automatic, 10 minutes, okay, and then you can remove them. So what probably in our C++ stuff was 200 lines of code is reduced to about 15 lines of code. That was one step forward in trying to make it easy for the clients. Registered profiles, same thing. To get to the basic profiles, you make the connection, you start the server object, you get the profiles. I want to get the SNI array 1.61 profile. I didn't put the try block in it. And then I go and get the central class, and right here, I'm now in 4 lines of code, and I'm setting up the central class. Of all the implementations we saw, very few implemented this correctly. Again, make it easy for the user. Okay, that's the basics. We are documented, believe it or not. We're well documented. I wonder if this will work. I hate to try it right now as soon as we get out of this, but we've got all of our API documentation, overview documentation, architecture documentation is done, and it's on Read the Docs. So we've got all the APIs documented. We've created a number of Jupyter notebooks. Everybody know what Jupyter is? It's a web-based notebook system that you can actually run code in. For giving examples of PyWBEM, we've got general usage, installation, developer support, etc., all in the documentation, and a changelog in the documentation. Where are we going from here? We're going to add some more function classes. There is a part of the model is jobs. That's things I want to run asynchronously. I send a method and I said, when you're done, get back to me. That's a job. And we want to implement the whole functionality for it because it's a rat's nest of code the way a lot of people did it. So we want to put that functionality right into PyWBEM so you can manage jobs with just a few lines of code. And the big one for us is we want to integrate the specific profiles, particularly for SMI, directly into probably a library parallel to PyWBEM. And that means the ability to define the resources, the relationships, the indications, etc., so that a user can get at them directly in a few lines of code instead of having to create all of that information for himself and then use us just as the transfer mechanism. Okay, so where we see ourselves going, here's PyWBEM. We've got tools working over here in parallel. We want to be able to create the profile definitions, which means the central scoping class mechanism, so that's all completely automated, which is largely there, just a few pieces missing. The resource classes, if this thing has got a SIM disk, we want somewhere in that particular profile, we want to automate the getting of that. We want to implement the profile methods and the subscription definitions. And this all sounds like a huge quantity of work. The advantage we got is a huge part of the definition is already done, and it's done as part of the development and testing of the SMI model, and that's all available in XML. So the biggest part of our work is going to be moving that into Python and making it available as resource classes. And that's what we're really working on right now. So, how a client profile works? Obviously, get the server first. We're not much help there. You got to know something. Get the profile you're interested in, get the central and scoping classes, get resource class instances, execute methods as Python methods, and then execute more complex functions based on the use cases, configure, create, et cetera, as specific methods. And what we're trying to do is implement as much of this in Python, so we'll end up with a class called array. And that is the array profile version blah, 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 blah. And that has in it the basic access tools for the resources, the associations, and the indication management for that particular entity. PyWBEM's got a number of support tools. We do operation logging, so you can turn on a log. Remember, PyWBEM is an infrastructure library. It's not an end user library, okay? So we had to build this in okay? So we built in an operation log so we can be used as an infrastructure library, and you can turn that logging on in the normal manner you would turn logging on for any other infrastructure component using the PyWBEM logger. This is all based on the standard PyWBEM logger. We have an automatic mechanism to always capture the last thing that happened. It's there. If you choose to capture it, you simply copy it and you make it available. We've got a recorder, operation recorder. It's more for us than anything else. We've got a MOF compiler. We got a very, very simplistic test tool. We got something that's much more complete elsewhere. And then we have written in this last version a complete server mock, so that using the mocker, I can say, here's the model, here are the instances, now run this against this code as opposed to running it against a real server. Okay, we've got the other packages we've got the tools package, which we're getting ready to release. And that's really this thing. The first part of it is a command line browser, and we hope to release that in October, seeing as how September's already over. Availability, it's available. Download from PyPy. Okay. It is a client package, already has been for years on some Linux systems. However, be very careful when you look at it, because a couple of them were really old. Red Hat was clear back 8 versions up to about 2 months ago. You can clone it directly from GitHub. We do about 2 releases a year. As I said, the documentation is complete as far as we're concerned. Anybody who wants to work with us, we use GitHub issues, and the pull request process in GitHub to manage the entire entity. We'd be very interested to get anybody who's interested in engaging in just problem fixes, working with it, or suggestions for the future. That's more. That's the references to the PyWBEM project, the GitHub. PyWBEM is one of several projects. Excuse me, PyWBEM is a project, and PyWBEM is also the client. So PyWBEM is the PyWBEM client on PyWBEM, and don't ask why. That's historic. Documentation is in Read the Docs. Okay. The Jupyter notebooks are available in Read the Docs also. That's it. Did I finish on time?
Yes.
Good. Anybody have any questions? Good heavens, no questions? I wanted to show everybody one thing here, which means I got to put on my glasses. This is the documentation on Read the Docs. Includes everything: concepts, overview, concepts, installation, the tutorial, which includes the Jupyter IPython code, detailed APIs for the entire environment. Thus, for example, here's the thing called the WBEM Operations. This is all of the detailed operations, and you can get to each one with 2 clicks. And that's the current up-to-date documentation in that operation. So we actually think we've documented this pretty well. We worked really hard at it, down to type definitions and everything else.
Does the documentation include examples, how to get started kind of stuff?
That's more in the IPython notebooks.
Okay.
You know. The advantage of having it in the notebooks is you can actually make them work. Okay, anybody have any questions? There's a whole set of extra slides in the back covering more details, but I didn't think we wanted to go through them. No questions at all?